Imagine walking into a laboratory where every single bottle has a different arbitrary name depending on who labeled it. You pick up a vial, but you can't tell if it holds a pure substance or a highly volatile mixture. Without a standard label, you're essentially guessing. This lack of clarity created a silent tragedy. Even if a researcher made a groundbreaking discovery, they had no common vocabulary to tell anyone else how to repeat it. In the 8th century Islamic world, scholars already had vast experience with metals, salts, and acids. The raw knowledge was there. But because that knowledge was scattered and disorganized, progress hit a wall. Science was stuck behind a massive systemic communication bottleneck. The naming inconsistencies were deep. A physician, an alchemist, and a craftsman might use the exact same chemical, but refer to it by completely different names. At the same time, different and dangerous substances were treated as identical, leading to ruined materials. This chaos meant that experiments couldn't be verified by peers. Without a common language, no one could be sure they were even testing the same materials. Valuable discoveries were consistently misunderstood, passed down with errors, or simply forgotten as researchers struggled to decipher each other's notes. Because information couldn't be reliably shared, much of a researcher's life was spent rediscovering basics that had already been documented elsewhere. Jabir ibn Hayyan was a figure who refused to accept this informational chaos as the standard cost of doing research. He identified the invisible barrier holding his peers back. They were trying to build a science on top of a broken system of identification. He asked a question that seems obvious today, but was revolutionary then. If a substance cannot be identified correctly, how can anyone possibly test it? He called on scholars to stop relying on tradition and guesswork, and to start looking at the physical evidence in front of them. This intervention required a shift in mindset, moving away from mystical interpretations and towards strict physical observation. Jabir's method began with a rigorous first step, the careful physical examination of every raw material in the lab. Instead of guessing, researchers had to compare the unique, measurable characteristics of different substances side by side. This led to the core of his work, classification. He grouped materials together into distinct categories based purely on their shared physical properties. By doing this, Jabir was effectively drafting the first shared vocabulary of matter, a stable, standardized framework for organizing data. This act of categorization provided the clarity necessary for researchers to finally move past isolated observations and begin building a collective body of knowledge. As these standards were adopted, the once isolated work of individual alchemists slowly began to link up into a more cohesive community of researchers. In an orderly environment like this, experiments could finally be repeated with accuracy by different people in different places. Jabir's system turned that early confusion into a manageable order. That order made widespread, repeatable experimentation possible for the first time. This ability to verify results became the driving force that pushed chemistry from a collection of secrets into a rigorous science. Long before modern textbooks or the periodic table existed, Jabir ibn Hayyan was laying the groundwork for the organized chemical communication we see here. He understood that you cannot discover the future until you fully organize what you already have. His vision helped transform scattered, local observations into a foundational architecture that scholars would build upon for centuries. By addressing that initial communication bottleneck, he provided the structural blueprint that allowed chemistry to evolve into a truly cumulative science.